Welcome to this lecture. In this lecture, we are going to study solvable groups, their definitions, example, and theorems. We have already discussed simple groups. When we discuss simple groups, our central idea is to discuss normal subgroups. Solvable ग्रुप्स की डेफिनेशन में भी नॉर्मल सब ग्रुप्स का एक सिग्निफिकेंट रोल है. जब हम बात करेंगे अबिलियन ग्रुप्स की तो वहाँ पर सिंपल ग्रुप का डिस्कशन ट्रिवियल हो जाता है. सो लेट अस स्टार्ट द डेफिनेशन ऑफ solvable group. Definition says the group G is said to be solvable if there exist a finite chain of subgroups of G, that is Z equal to N naught, that contains N1, that contains N2, contains, and so on, contains N that has to be equal to identity, such that it is following three conditions, and these conditions are: the first one is given by the normality. Okay, each Ni is normal in its preceding one. Okay, normal subgroup of Ni minus 1 for I equals to 1, 2, and so on n. Okay, then we have that since each Ni is normal in Ni minus 1, so we can talk about Ni minus 1 over Ni as a quotient group. Okay, then Ni minus 1 over Ni, because this subgroup is normal in this, so we can talk about this quotient group. So it has to be is abelian for I equals to 1, 2, and so on n. Okay, then this is the also important property that the whatever the last index is, the last normal subgroup that contained in every normal subgroup has to be equal to identity. Okay, so whenever we want to determine that whether a given group is solvable or not, then for that particular scenario we need to find the existence of this chain. Okay, we always need to find the existence of this chain which follows these three conditions, that each Ni is normal subgroup of Ni minus 1, then Ni minus 1 over Ni, that is the quotient group, is abelian, and the last normal subgroup that contain in each and every normal subgroup of G, that has to be identity only. Okay, so this is about the definition. Let us discuss some example that make this definition more clear. So this is the example. I'm writing the number as per your book 7.6.1, that show that S3 is solvable. Okay, solution. तो जब कभी भी हमें किसी भी ग्रुप को सोल्वेबल दिखाना है तो उस केस में वी नीड टू आइडेंटिफाई द एग्जिस्टेंस ऑफ अ चेन दैट फॉलोज दिस थ्री कंडीशन. ओके, सो लेट जो भी हमें ग्रुप गिवन है टेक इट एज एन नोट. ओके, सो लेट S3 is equal to n naught. Okay, then we know that in Sn, An is always a normal subgroup of Sn. So we can come to, or you also know that after Sn, in Sn, An is the largest normal subgroup, or we can say An is the largest proper normal subgroup of Sn for every value of n. So secondly, we can consider let n naught equals to n, S3 is equal to n naught, then A3 equal to n1, and the identity of S3 that is equals to n2. Now you can see, like this is the chain of normal subgroups. Basically हम क्या लिखेंगे यहाँ पर? So first of all, n naught, n1 and n2 are subgroups of S3, राइट? ये तीनों ही सबग्रुप्स हैं. हम क्या लिखेंगे? सबग्रुप्स ऑफ S3 following this n naught contained n1, this n1 contained n2. Okay, we have this conditions, or you can say this constraint for these three subgroups of S3. Then we have, ये लिखने के बाद we will examine the first condition. Okay, क्या n नोट n1 में n नोट के अंदर n1 नॉर्मल है? So let us identify that. We know that A3 is normal in S3, so we can write n naught or n1 normal in n1. Okay, then every identity subgroup is normal in every non-trivial subgroup of any group, so we can write this n2 is normal in n1. Okay, so for each I, every ni is normal in ni minus 1. Then let us talk about n naught. First of all, let us talk about n naught over ni. Okay, this is same as S3 over A3. We know, since S3 over A3 is isomorphic to, its order is 6, its order is 3. तो इन दोनों का ऑर्डर कितना होगा? 2. मतलब इस क्वेश्चन ग्रुप का ऑर्डर कितना होगा? 2. और एवरी ग्रुप ऑफ ऑर्डर 2 इज आइसोमॉर्फिक टू Z2 एंड Z2 इज साइक्लिक. और हमें प्रिसाइजली क्या चाहिए? अबेलियन. सो हम क्या कह सकते हैं? S3 over A3 is isomorphic to Z2, therefore and Z2 is cyclic, hence abelian, right? अबेलियन भी होता है, साइक्लिक होता है वैसे तो, बट साइक्लिक है तो अबेलियन भी है. Therefore we can say S3 over A3 is abelian, right? Now this is the first one. Then second one you can consider n1 over n2. Now we have this one is A3 over the identity subgroup, right? Now this group has order 3, this has order 1. So the resultant quotient group A3 over the identity will be a subgroup of order 3. That means this has to be isomorphic to Z3, and since this 3 is prime, 2 was prime, that's why we have written this one, and Z3 is cyclic, and more precisely it is abelian, right? So we can say since Z3 is abelian और cyclic भी है ये, ठीक है. Therefore A3 over the identity subgroup is abelian. So we have that. Thus we can say ni minus 1 over ni is abelian for I running from 1 and 2. Okay, so the second condition is also satisfied. Then come to the third one, and third is one is not has kind of discussion at all. So this is the identity subgroup, and यही हमारे पास थर्ड कंडीशन के लिए होना चाहिए. Okay, so we can write hence S3 is solvable, right?